We know that tiny little atoms make up matter. Can you imagine what they look like? They could look like this, or even this. It is difficult to imagine the shape or structure of something we have never seen, isn't it? The same applies to atoms. It took hundreds of years of theories and discoveries to finally understand the structure of an atom. So, buckle up because we are going to take you on a trip back in time to see the events that led to our present understanding of the atom. Maharishi Kanad in the 6th century BC first gave the idea of an indivisible tiny particle that makes up matter. He called it Parmanu. According to him, Parmanu does not exist in a free state but rather combines with other Parmanus to form a bigger particle called Anu. A few hundred years later, the Greek philosopher Democritus proposed a similar idea of an indivisible particle. He called it atomus, which means not cuttable. In fact, the term atom that we use today comes from the Greek term. Well, isn't it always the Greeks? Then came Aristotle, another Greek, and one of ancient history's greatest geniuses. He refuted Democritus' theory of the atom and suggested that matter is not made of particles. He believed instead that different substances are made up of a combination of the 5 elements: fire, air, earth, water, and ether. Aristotle, Democritus, and Kanad were philosophers whose ideas were not based on experimental observations. As years progressed, there was a shift from philosophy to experimentation. Scientists began experimenting with different materials to understand what actually makes up matter. At the turn of the 19th century, Dalton gave us the first ever atomic theory based on his experiments with gases. This theory proposed that all matter is made up of tiny indivisible particles which he called atoms. He imagined them as solid balls. You've already learned that Dalton's theory successfully explained the law of conservation of mass and the law of constant proportion. But it failed to explain one thing. How can an atom become electrically charged? Electrically charged? Now what's that? Try rubbing a scale over a woolen cloth and then bring it close to some bits of paper. It attracts them. Even if you wear woolen clothes for a long time, you may feel a sudden shock when you touch something. All these are examples of neutral objects becoming electrically charged. Scientists knew that matter and the atoms that make it up are neutral. Then how can objects become electrically charged? In trying to answer these questions, scientists studied rays emitted by atoms. In the process, they discovered negatively charged rays and positively charged rays. They imagined these rays as waves traveling in some sort of an unknown material called ether. They did not know what these rays were made up of. Luckily, Thomson soon made a ground-shaking discovery. He found that negatively charged rays are actually a stream of negatively charged particles. These particles were called electrons, a name given by Stoney. Electrons were found to be very small in size compared to the atom. And it is because of them that objects can become electrically charged. Electron was thus the first subatomic particle to be discovered. But this raised a question. Why is the atom neutral if it contains negatively charged electrons? Also, where are the electrons placed in the atom? So many theories and discoveries, but we still do not have a clear picture of the atom. I'm sure this must be boggling your mind too. Over the years, scientists proposed different models to explain the structure of the atom. We learn about these in the upcoming videos. But for now, let's quickly recall what we've learned. Maharishi Kanad first gave the idea of an indestructible tiny particle called Parmanu. Democritus proposed a similar idea of an indivisible particle and called it atomus, meaning not cuttable. Dalton proposed that all matter is made up of tiny indivisible particles called atoms, which look like solid balls. Dalton's theory could explain the law of conservation of mass and the law of constant proportion. However, it failed to explain why matter becomes electrically charged. Thomson discovered that negatively charged rays are made of negatively charged particles. These were named electrons by Stoney. Electrons were the first subatomic particles to be discovered. That's all for now. We'll soon see how the best minds of those times tried to decipher the atomic structure. Keep watching.